Welcome to David Alexander Maths Tuition. This is chapter 6D on intersections of straight lines and graphs. So first off, find the coordinates where the circle x plus 5 squared plus y minus 3 squared equals 49 meets the x-axis. So whenever in A-level maths you see this phrase meets the x-axis, you need to automatically think, y is 0. Y is always 0 on the x-axis. So if y is 0, we can substitute 0 into this equation. So therefore x plus 5 squared plus 0 take away 3 squared, well 0 take away 3 is negative 3 squared is 9. So x plus 5 squared plus 9 is 49. So now I can subtract the 9, so therefore x plus 5 squared equals 40. X plus 5 will therefore equal plus or minus the square root of 40, so therefore x is negative 5 plus or minus the square root of 40. So remember that this is a circle, so there's a good chance we're going to get two solutions. It could cut through in two positions. This is not an accurate sketch, by the way. So one of the coordinates will be minus 5 plus root 40, 0, and the other one will be minus 5 minus root 40, 0. Now, similarly, when we've got this expression meets the y-axis, this is very similar to the question above, except this means x is 0. So let's substitute in 0 for x. 0 plus 2 is 2, 2 squared is 4, 4 plus y minus 5 all squared is 49, so therefore y minus 5 squared is 45, so y minus 5 is plus or minus the square root of 45, so therefore y is 5 plus or minus root 45. So the coordinates here are 0, 5 plus root 45, and 0, 5 take away root 45. There we go. And again, a bit like in my sketch here, you can see there are two possible solutions. If you only get one solution, that shows that either the x-axis or the y-axis would be a tangent to the circle. Okay, so here's a slightly harder example. So what we need to do here, basically we've got some simultaneous equations. I'm going to rearrange the linear one to make x the subject, or I could make y the subject if I wanted to, and then substitute into the circle equation. So if x take y take 5 is 0, then that means x is y plus 5. So if x is y plus 5, I'm going to replace this x with y plus 5. So y plus 5 take 4 squared plus y plus 7 squared equals 50. Now y plus 5 take 4 is y plus 1. So that can become y plus 1 all squared plus y plus 7 squared equals 50. Let's expand the brackets. I'm going to get y squared plus 2y plus 1 plus y squared plus 14y plus 49 equals 50. Let's tidy it up a little bit. That's going to be 2y squared plus 16y plus 50 equals 50. Subtract 50 from both sides, so 2y squared plus 16y equals 0. Divide by 2, y squared plus 8y equals 0. Factorise, y, lots of y plus 8 equals 0. So therefore y is 0 and y is negative 8. Now the x values are y plus 5. So when y is 0, x is 5, and when y is negative 8, then x is negative 3. So the coordinates are 5, 0, and negative 3, negative 8. Okay, so here we need to show that this line doesn't meet the circle. So a line could meet a circle twice. There could be two solutions. There could be one solution. That would mean the line is a tangent to the curve or to the circle. And here we are showing that there are no solutions. So the line completely misses the circle. Now we know that y is 2x take 7. So I'm going to replace this y with 2x take 7. So what we'll have is x plus 6 squared plus 2x take 7 take 8. In other words, 2x take 15 squared equals 25. Expand out both sets of brackets. That's going to be x squared plus 12x plus 36 plus 4x squared take away 60x plus 225 is 25. Let's tidy it up. So that's going to be 5x squared minus 48x. 225 plus 36 is 261. Plus 261 is 25. Take away the 25 from both sides. 5x squared, take away 48x, plus 236 equals 0. Okay, so to show that there are no solutions, we need to be looking at the discriminant, b squared minus 4ac. Now, if it is negative, if it's less than 0, that means there are no solutions. So what we have is minus 48 squared, take away 4 times a, which is 5, times c, which is 236. Now 48 squared is 2,304, and we are subtracting 4 times 5 times 236, which is 4,720. I mean, we could work this out, but it's fairly obviously going to be a negative answer. So minus 2416. So because the discriminant is less than 0, there are no solutions to this quadratic equation. So therefore the line does not meet the circle.